So, good evening, my dear students. So, I am S. Krishu from Sri Chaitanya Techno School, Sri Chaitanya Junior College. No, I came to 11th, no. So, here they call it as Junior College instead of 11th standard. That is one beautiful thing. So, today's video we are going to discuss about the interesting chapter which is known as the collisions. In one day only, we are going to discuss 2D, we won't discuss right now. So, in 1D, what and all we are going to discuss means we are going to discuss concepts, formulas, and then we are going to discuss few JEE mains questions and JEE advance possible, if possible JEE advance. Mainly focus for JEE mains over here. Okay. Okay, fine. We'll start. So first, what do you understand with the word collision? Collision means one particle is going to hit another particle. So let's tell that there is one particle of m mass, another particle of m mass, and this is traveling at the velocity u1, and this is traveling at the velocity u2. Okay. So what is the condition for this mass to collide with this mass? Definitely u1 must be greater than u2. Fine. So can I tell that momentum is conserved everywhere in the collisions? Yes. Momentum is conserved everywhere. So you can expect after time t. Okay, you write this t is equal to 0. At t is equal to 0, the initial velocities of the particle is u1 and u2. Okay, after t is equal to t collision. During the moment of collision, after the moment of collision. Okay, t is greater than t collision. Okay, t greater than t collision. So the same masses going to move the velocity v1 and v2. So by conserving momentum now, by conserving the linear momentum, we'll get m1 e1 plus m2 u2 equal to m1 v1 plus m2 v2. And one more thing you can tell that in elastic there are three types of collisions basically. So first type is that elastic collision. So this particle is going to collide with this particle and there's no deformation. Okay, there's no deformation, and we'll discuss about coefficient of restitution which is denoted by E. Okay, this coefficient of restitution will be equal to 1 in case of elastic collision. Don't get confused, I'll discuss. So here everywhere in the collision chapter we are going to conserve momentum, that is for sure. Okay, until and unless internal energies are there. Okay, we'll talk about that later. So T must be greater than T collision. During the collision time, V1, V2 is not possible. Okay, after collision, V1, V2 will be there. During the time of collision, normal reaction will be there. Okay, so by conserving linear momentum, we got this relation. And so there are three types of collision. One is elastic collision, one is inelastic collision, one is perfectly inelastic collision. So first type is elastic, second type is inelastic, third type is perfectly inelastic, and one fourth type is there which is called as the super elastic collision. So the super elastic collision, no, it is a hypothetical concept, so it's not there in our syllabus. You will study in your college time, so we are not going to discuss this one. Okay, we are not going to discuss this one. The remaining three will be discussing here, and this has less weightage. In the sense, there is no need for you to study this specially. By studying elastic and perfectly inelastic, you can automatically solve inelastic. Okay. So elastic collision in sense there will be no deformation and coefficient of restitution will be equal to 1 means that momentum is conserved at the same time kinetic energy is also conserved. In the case of elastic collision, elastic collision, momentum is conserved. Momentum conserved and kinetic energy conserved. So these two are getting conserved in elastic collision. So wait a minute, I'll just erase the board. Okay, fine. So now we are going to discuss what is coefficient of restitution. Coefficient of restitution. Okay, so this coefficient of restitution is denoted by E. Okay, E is nothing but coefficient of restitution. How can we define coefficient of restitution in the sense? Relative separation of final velocities, that is V2 minus V1, divided by relative separation of initial velocities, which is known as U1 minus U2. Okay, this is U1. U1 minus U2. So this is what coefficient of restitution in case of elastic collision. E will be equal to 1. In case of perfectly inelastic collision, E will be equal to 0. For inelastic or semi-inelastic collision, both are same. E will be greater than 0 but less than 1, but never equal to 0, never equal to 1. So this thing you need to remember. Just we will go very fast in this lecture. Don't expect slow teaching because we need to cover a lot in very short time. Okay, fine. This is coefficient of restitution. So these are the values for different cases. And now we'll go. First, we are going to discuss about elastic collision only. In elastic collision, like I said, momentum is going to be conserved. That is m1 u1 plus m2 u2 is going to give m1 v1 plus m2 v2. Without this, another thing is going to happen. Okay, leave it as elastic collision. We consider some kind of collision is going to happen. For this collision, some restitution is there. Let's say E restitution. Since restitution is denoted by E, let us keep it as E itself. Okay. So what can I do with that E? Oh, okay. We'll discuss first elastic event. In elastic, kinetic energy is also conserved. In kinetic energy conservation, we can tell that half m1 u1 square plus half m2 u2 square equal to half m1 v1 square plus half m2 v2 square. So for those brilliant students who don't know what is kinetic energy, let me tell that kinetic energy is formula as half mv square. Okay, half mass into velocity square. M is not slope for math students. At the same time, okay, M means what? Mass here, not slope. So now you tell me. We know the what is E. We know V2 minus V1 by U1 minus U2. Now can you think no? V2 V1 is unknown. This is one equation. This is one equation. This is one equation. Three equations are there. Can you write here V1 and V2? V1 and V2 can be written. I'll just write and show you. So these are the two formulas that you need to remember. That is derived through those three equations. So they don't keep deriving in the examination. That is going to kill your time like something. So first, velocity of the first body after collision. This is the formula. If it's elastic collision, keep E is equal to 1. If it's inelastic collision, they will give the value. If it's perfectly inelastic collision, then E is equal to 0. If nothing is given and they did not mention elastic, but they are telling it's sticking together means it's inelastic. Sorry, perfectly inelastic, you can consider as 0. Or they simply told it is inelastic and they did not give the value of E, then you can consider it as perfectly inelastic itself. Okay, so it's the case, or else you will get in the answer in terms of E even. In the options, there will be given answers in terms of E. Acha, this is U1. Yes, some weight like this, that this is U1. Okay, don't get confused, this is U1. Okay, so these are the two formulas you need to remember. And now let's go for some questions. Everything discussed, no? Yes. So let's say so this is a slab. We have a mass of block M here, and there is one bullet, okay, of mass M traveling with the speed V naught. Okay, this is at rest. This is at rest. This is important now because we are solving questions. Now, can you tell that if I'm telling that E is equal to 0, that is, it's a perfectly inelastic collision, can you determine the final velocity after the collision takes place? Determine final velocity, combined system, how much? So, can you take a feel that, can you get the feel that this mass is going to be embedded with this mass and both are going to move the same velocity? Initially, it's traveling with a different velocity, but after striking, both the masses are going to travel with the same velocity. Fine. So can I conserve linear momentum here? Conservation of linear momentum. M v naught plus m, what is the velocity? 0. Now what is final momentum? Total mass. M plus m with some velocity, final velocity. Now they are asking final velocity only. So Vf is equal to m v naught by m plus m. Some students are telling sir this is equation. I know, that's why we slowly will increase the standard. This is the one example of perfectly inelastic collision. Now let's go get into another example. Just copy, pause and copy firstly. You keep in 2x speed and watch. Okay, already I'm talking in 2x only. If you're keeping on is an example of 4x speed. So YouTube feature doesn't give 4x speed options for you, but no, I will give that options because we are going to go that much speed. Okay, this thing what I have discussed will be taught for 1, 2 to 3 days. Normal CBSE schools, not in J classes. Okay, so since we need to rush, we'll go with another example. Let me tell that there is a mass of 1 kg block here, 2 kg block moving with the speed 5 meter per second. This is at rest. Okay, this is at rest. Find Vf of particle 1. A particle 1 kg. Let's pick as 1 kg. Find it out. Find it out. So how can we find the velocity of the particle of 1 kg? Directly we can use formula, right? Okay, here collision is elastic. Now we can do it. Elastic collision is happened. Now can I tell that directly with formula V1 is equal to m1 minus em2 by m1 plus m2 u1 plus 2m, okay, not 2, fine. 1 plus e m2 u2 by m1 plus m2. Now do you observe that u2 is 0, so the entire term will get cancelled. And here what is mass 1 kg minus elastic e value is 1, mass 2 is 2 kg, 1 plus 2 is 3, u1 is 5. Sir, velocity is coming negative. Okay, I'm not sir, leave it. Brother, okay? Because I don't have a teacher degree on that. V1 is equal to minus 5 by 3. Can anyone tell why it is minus? Does that mean that our calculations are wrong? No. If it is according to a formula only, then why we are getting minus n over here? Because the particle, no, after collision, this ball is going to go in the leftward direction. Okay, rightward direction positive, leftward direction negative. Not in all the cases. Initial direction you take it as positive. If you are getting negative, that means it is going in the opposite direction. Right? So one good observation. And why I gave this question? Like CBSE classes directly I can go with 1 plus. After 2 days now I can go with 1 minus. I won't do that because we need some standard. Okay, this is the standard I can give to you. Let's increase some standard now. Okay, can we go for one tough question? What do you say? Can we go for one tough question? It's not tough. If you think it's tough, it's tough. If you think it's easy, it's easy. So what's that special question? Let me tell you. It's just know you strike it. Okay. Given that after bullet strike, both particles both particles travel together in vertical circular motion. VCM na vertical circular motion and complete one revolution. One revolution. Okay, and the speed of the particle is minimum. To complete this vertical circular motion, minimum velocity is needed. Okay, they are asking the minimum velocity of V naught. Find V min, V naught min for vertical circular motion of with one revolution. Okay, and given that the string of length is L, now tell how to solve. How is the standard now? Still same, huh? Anyone telling still easy, sir? Hope it's not the same case. But some students will be there. Sir, easy, sir. So, kindly copy this question. I want to erase this. Okay, let me erase. You just copy. Okay, let me draw the same diagram here. It's a block of mass m and a bullet of mass m moving with the speed v naught, and it's going to come length is L. Okay, fine. So from particular circular motion chapter, can you tell me what is the minimum velocity required for the pendulum to complete one full revolution? Given that the radius here is L, so we know that the speed require speed is root 5 gr. What is r here? R is L. So can I tell that required speed is root under 5 gl? Required minimum speed is root 5 gr. Any speed above this is gonna go for one full loop. Okay, it's gonna travel one full loop like this. Okay. Now can I conserve momentum? Yes, of course. Initial momentum. What is initial momentum? Pi m v naught plus capital M into 0, because this is initially at rest. This is initially moving with v naught velocity. And can I tell that final momentum? Both are gonna travel together with some speed. Final velocity. So from this I can write that m plus m into final velocity is equal to m v naught. Same relation will get Vf is equal to m v naught by m plus m. Now I can tell that this minimum velocity Vf, minimum velocity is nothing but root under 5 gl. Root under 5 gl. From this can I write that v naught is equal to m plus m into root 5 gl by m. Okay. Once again analyze this question. So this particle is going to strike this particle and move together. So I can conserve initial momentum, final momentum. Initial momentum is mv naught. Here initially this is at rest, so m into 0. Final momentum is going to travel together, so that I can tell m plus m into vf. And this is vertical circular motion. So in vertical circular motion, what is the minimum speed required with a bob to complete one full revolution? ಇಲ್ಲ ಮೂಂಜಿ ತೇವಲ್ಲ ಸುಮ್ಮ ಇದು ಕಂಟೆಂಟ್ ಅನ್ನು so minimum speed for completing one full vertical circular motion is nothing but root under 5 gr, where r is the radius, but here instead of r we are having length of the rope, which is L. Fine. So instead of r we are going to replace L, which will result in root under 5 gl By conserving momentum, we got Vf is equal to mv naught by m plus m, and we can replace Vf by root under phi gl. With that, I just found V naught. That's it. Nothing big I did. Okay. This is one good question. Just copy this. Anything got blurring? No, no. Okay, fine. Okay, I'll come with the next question. You just copy it, pause and copy. One more nice question. Let us see. A particle of mass m, I am dropping from a height h. Okay, this particle I am dropping from a height h. So can you tell me, find the final velocity of the particle after nth collision, such that coefficient of restitution here is given as e. Fine. Now tell how to find. How to find. Now can I tell that this ball is over here, particle is over here, and now I'm going to drop this particle. So it's initially going to go with the speed of u. What is the value of u? Root under 2gh from kinematics chapter. Fine. Again, it's going to rebound like this with some velocity v. And can I tell that? Okay, wait. With v in the same line. Okay, same line. Can I tell that this is the line of impact? The same line of impact only, velocity is getting changed. So directly I can write v is equal to eu. Can I? This formula, no, this I wrote from the this one only, v2 minus v1 by u1 minus u2. You substitute the given quantity. This is particle 2, this is particle 1. So u1 will be u1 will be u, u2 will be 0, v1 will be, that's what we need to find. v2 is going to be 0. With that, if you find now, you will get v1 equal to v equal to minus u. Okay, minus u. And then minus I'm not neglecting because minus just shows the opposite direction. Okay. So okay, no problem. Now again, this process is going to continue. The second collision. The second collision is going to go down with the speed of v. Okay. And again rebound with the speed of v dash. So can I again tell that v dash is equal to ev, and v is equal to minus over here, right? Yes. You take magnitude. So can I write v is u? So v dash is going to be e square u. Observe. This is where you need to observe. First collision, v equal to e power u. So let me tell you v1. First collision, e power 1u. Second collision, we got e power 2u. So third collision, if you solve and check, you will get e power 3u. Now can I tell that during the nth collision, speed is going to be e power nu, and they are asking in terms of h. So Vn is equal to e power n root 2gh. Simple. Simple. So after nth collision and each collision, no, V is going to be E times Uy, final velocity of the particle. After collision, initial velocity is on the same line of impact. Line of impact is the place. See, when this is touching this part, colliding with this particle, this floor and this ball is going to collide. At that time, where is the normal? Okay, like this. Whereas the line of impact is also like this only. Now, for better understanding, let me write two balls like this. After collision, or during the moment of collision, their line of impact, these may be traveling in this direction, but line of impact is like this. Okay, can you understand? Like that, here line of impact is like this. So directly I can write V is equal to E times U with the formula, with the help of this formula. If the impact is something like this. It won't be, but for example, assumption, very okay, that's a wrong assumption, but just for make you understand, if the line of impact is like this, then you need to take the component with the line of impact. Okay, then you can substitute here. You'll get the answer. That we'll discuss in 2D. But now you need to know that along the line of impact, V can be written as V times U. And just copy. I want to discuss one more question with the same question. What is the height of the particle traveled after nth collision? Nth collision height is what? To calculate nth collision height directly, we can use the help of kinematics. What is that? S is equal to ut plus half at square. Why am I using this equation? Tell me. Why am I using this equation? Can I use this equation everywhere? No. Here acceleration is constant. In case of string and all, no. F is equal to kx. Then what will be the acceleration? F by m, which is kx by m. Directly don't substitute like this. Kx by m will change each and every distance. Acceleration there is a function of elongation or compression. There you cannot use this formula because acceleration is not constant. But here acceleration is constant in each and every instant. G acceleration is going to act, which is downwards only, not upwards, only downwards every time. So acceleration is constant. So I can use this formula, direct formula, or else I need to go for integration. Should be clear. Should not directly believe all formulas. So can I tell that here S is nothing but Hn. Hn is equal to ut. This is t, sorry. This is ut. Initially this is dropped, right? Dropped. Drop now 0. 0 into t. 1 minute, am I doing in mistake? C. I'm making mistake. This formula should not be used. No. This formula should not be used. That formula is applicable, but that is for finding time, not for height. Here you need to go with the formula v square minus u square equal to 2as. Here also, why I am using this formula? Acceleration is constant. Direct formula. This is v square. I need to write in the top. Okay. Okay, fine. V square is nothing but vn square. U square is nothing but, since it's dropped, it's 0. 2 times g times this is hn. So I can write vn square equal to 2g hn. So height of nth collision will be vn square by 2g. Now we know what is vn. What is vn? This is vn. E power n whole square into 2gh divided by 2g. So from here I can write hn equal to e power 2n h. What is h? Initial height. So in the exam, if they asked height attained by the particle after third collision, you directly substitute n is equal to 3. That will give you an answer. Okay, if you directly substitute n is equal to 3, then you will get e power 6h. E value, if it is 1, directly you get hn is equal to h. From this part you can observe with what velocity is going down, with the same velocity is going up. So that only is covering equal height in case of elastic collision. What if it's e is equal to 0? Hn is equal to 0. For any value of n, you take e is equal to n is equal to k. Then e is equal to 0. 0 power k, 0. Okay, if 0, then assume, not assume. That is only correct. Take first collision. Keep e is equal to 0 and take n is equal to 1. What will happen? Sir, first collision even 0, sir. Means what is happening? This mass will stick with this. It won't rebound. So that is the perfectly inelastic collision. Okay. That's the perfectly inelastic collision. That rebounding won't be there. I mean, It won't again come back. It won't bounce back. So this is the relation you need to know. It's important. You need to know. And now, let's do another beautiful question. This is the last question, I guess. Important questions only I'm discussing, not all the questions. Okay, all the questions anyone can do. If you know the concept now, most of the questions you can do. Only some questions you can't do that I will explain. Let me tell that. So it's 90 degree, and the particle have mass of m. It's drop. This is of mass m. This is of height h. So this is drop. If this is drop, can we tell that the initial final velocity that is here, the ball's velocity here is going to be what? That is the question. And E is equal to 0. So it's going to be a completely perfectly inelastic collision. Just a second. Okay, so and so now we need to find out what is the final velocity of the system. Okay, it's going to stick with this. That's the final velocity of the system. They won't ask final velocity in the exam. They'll ask speed of v1, speed of v2 like that. But don't get confused. No, there is formula. No, for simplicity, I took like this. So here, can you tell that I will assume this line as reference line for potential is equal to 0. Then now tell what is the height of this particle h. Okay. After some time, it's going to reach somewhere over here. When it is reaching here, what is the height of the particle? H is equal to 0. At here, u is equal to 0. But here, some velocity will be there. That velocity we need to calculate. Don't worry. Can I conserve energy from here to here? Do you think any loss of energy is going to happen? No. There is no collision, so collision is happening only here. So I will conserve energy there. How can I conserve energy there? Initial energy, potential energy is mgh plus half m0 square equal to mg0 plus half mv square. Okay, from this I can write v is equal to root 2g. How sir? Simplified. This also we need to do half mv square is equal to mgh. This cancel, this cancel. M cancel. P is equal to root under 2gh. Where when the particle is here, you will get the speed as root under 2gh. Okay, this is at rest. After collision, can I consider momentum now? Mass, initial momentum, Pi. Mass into root under 2gh. And plus mass into 0. Final momentum, both are going to be moving together. So m plus m into final velocity vf. By equating both of them, we'll get vf is equal to m root 2gh divided by m plus m. So this is the final velocity of the combined system. Hope this is clear for you. So with this, no, one more concept is there. Just remember that formula only. Write that formula. Later I can start some. Energy lost by the system. Actually, you can do it with unwanted waste of time so that time can energy lost by system. Or energy lost by system will be equal to, let me tell you.
So energy lost by system is, or a change in energy, we can write it as half m1, half m1 m2 by m1 plus m2 into u1 square minus u2 square into 1 minus e square. Okay, this is the formula. Just note it down. Okay, with this we are going to wind up. So thank you for watching. I hope it's helpful for you. These are standard questions, kindly practice again and again. And one more model is there, like a block will be released from here. Okay, like this, and this surface is smooth, so that when this is going like this will go like this. Okay, that part of thing, no, that will come with the center of mass concept, so that I did not take that. But if you know center of mass contact, center of mass concept, then you can do that also. It's problem, I will tell the clue also. Del x com will be 0, that's it. And del x com, if you differentiate with t now, d by dt of del x com, that will also be 0. So velocity of center of mass will be 0. At the same time, acceleration of center of mass also 0. Okay, with this you try that one. Okay, thank you for watching.